Now the area enclosed by the curve mod y equal to minus of 1 minus mod x square plus 5 is dash square units. Now we need to find this curve. Now before we proceed to find this curve, let's observe one very important observation. The graph of mod y equal to minus of 1 minus mod x whole square plus 5 is symmetric in all the four quadrants. Now you may be wondering how we reached this conclusion. Yes, if the function has f of xy value same as that of f of minus x comma y, then we will say the graph in first quadrant will be same as that of the graph in second quadrant. Now if this is also equal to f of x comma minus y, then the graph is symmetric with respect to x-axis from first and fourth quadrants. And if this is equal to f of minus x minus y, then the graph will be symmetric in all four quadrants. Now as you can see here, mod y and mod x, both x and y are present inside modulus. So this equation remains unaltered. By interchanging x with minus x and y with minus y, the equation remains same. So can we first try to plot the graph of this in the first quadrant? For x to be more than 0 and y to be greater than 0, that is we are talking only about the first quadrant. How will be the function? Y equal to 5 minus of 1 minus x whole square, right? This is clearly a parabola cutting y-axis at 0, 4 and x-axis at 1 plus root 5, 0. Now as the graph is symmetric in all four quadrants, this is the graph only in the first quadrant. What can you say about the graph in the remaining quadrants? By symmetry, in the second quadrant the graph will be mirror image with respect to y-axis. Then in fourth quadrant the graph will be mirror image with respect to x-axis to that of the graph in first quadrant. And in the third quadrant it would be image of the second quadrant's graph with respect to x-axis. So now we are able to identify the total region required. And now the requirement is quite simple. We need to find the total area bounded by this graph. And by symmetry, the required area is 4 times the area bounded by the curve y equal to 5 minus of 1 minus x whole square with x-axis, right? And that multiplied by 4 times. That means we are trying to calculate this area and the rest all 4 areas would be same. Now for this we know the limitations. It starts from x equal to 0 and up to x equal to 1 plus root 5. So this would be 4 times integral from 0 to 1 plus root 5. Which function to be integrated? 5 minus of 1 minus x whole square, right? Now this is 4 times, the function is 5 minus of 1 minus x whole square dx. Now the function can be expressed as a polynomial as 0 to 1 plus root 5 minus x square plus 2x plus 4 dx, right? Now this integral can be calculated comfortably, which comes to 8 by 3 times 7 plus 5 root 5 square units. Let's search for a suitable option here. It is 8 by 3 times 7 plus 5 root 5. So correcting the first option, this would give us 8 by 3 times 7 plus 5 root 5. As both A and B are appearing same, we'll make a small correction at the choice A, which happens.